Okay, so we have one more video here this week for scientific method. So the scientific method is described as a series of steps used to solve a problem. It's organized common sense. You used it just now. How am I going to learn? Oh, I'm going to go online and I'm going to click on the video that Mrs. Norcross has set up. I'm going to listen to her and then I'm going to learn from that. So the first thing you do is always state the problem, the question. They usually start with how, when, what, who, why, which, where. The questions have to be measurable. I have on the thing here, how do I become untangled from this rope? Hopefully you're not tangled in rope. But you could easily say, how am I going to get to school on time? You then do a little research. When you're using this every day, you don't go to the library, you don't go online, you don't Google, how am I going to wake up on time? You don't say, Siri, how am I going to work on time? You say, Siri, set my alarm for 6:45 a.m. You use information from other people that have already discovered it, or if something you used, like from last year. If I have to be to school and in my first period class by right now 8:49, and I have to be heading towards the school and walking in the door by 8:40, then I need to wake up by blah blah because I have 20 minutes to walk, or the bus is going to pick me up at 7, so I have to be there 10 minutes before the bus. I could go on and on and on here. You don't start from scratch, and it's not always a scientific experiment that you're using this with. Your hypothesis in here is always going to be an if, then, because statement. If I set my alarm for 7, then I will wake up at 7:20 because I snoozed twice. And I will be on time to school because it only takes me 10 minutes to brush my teeth, grab something to eat, and get dressed and get out the door, and my bus comes at 7:30, and then it arrives at school at 7:40. The experiment is going to be written like a recipe. 1, 2, 3, 4, or in a paragraph that makes sense in a sequential order. And then you perform it exactly how you would do it. Normally in class I'd have the kids write directions for a peanut butter and jelly sandwich, and I actually might do that in class this year just to give you an example. And you guys will just play along. It'll be something we do in the in-class sessions. But literally you'd be like, 1, set alarm. 2, type in time. 3, click the knob over. 4, make sure it's set. 5, go to sleep. 6, alarm goes off. 7, brush my teeth. 8, get a shower. 9, eat breakfast. 10, walk downstairs, grab book bag. 11, walk outside. 12, get on bus. The data that you collect is usually going to be in numbers because numbers can be easily graphed. However, you can also do surveys with humans with yes and no's, which can then be tabulated like into a counting system. It's all going to go whether it's qualitative or quantitative data. Quantitative is easier to use with because you can graph it. Qualitative is harder to graph. You can put it in tables and charts though. You analyze it then. The next step of the scientific method is to data analysis. It's not make a graph. The graph is what you use to analyze. Your tables are what you use to analyze. Analyzing is when you write a statement. And it's usually like, was your hypothesis supported by the data? Was I correct? You have to ask yourself, is there more, or was it not supported? Was I incorrect? Is more data needed? Was I not correct one time, but then I was correct another time? If you answer yes to 1, 2, or 3, you then have to do something that you're going to have to do some anyways, which is repeat. In order to have a successful experiment, you must repeat at least 3 times. If you were doing the science fair, we suggest repeating it 5 times, 5 different trials, which would mean that you would have done the same thing 5 exact times, side by side by side by side. So if you had plants growing and you had 5 plants in your experiment, you would have 5 windows now with 5 plants in each window, and that would be your 5 different times you're doing it in different windows in your house. So you'd have 25 plants total. That's a little low on the number of plants, but that, I mean, because if you're doing a real experiment, you'd have to have way more plants in your trials. And then again, you always repeat 3 times. So, steps to the scientific method: state the problem, do some research, make a hypothesis, an if then because statement, test your guess for your experiment, analyze your data, meaning come to a conclusion, write it out, And then you must repeat that 3 times before you summarize, conclude, and publish. Remember, repeat it 3 times. So there are a few things that you need to know here. Variables and controls. So the variable is what you change and it's what you measure, and you can only ever have one of them. So if I'm going to do a plant experiment and I have bean plants and I want to measure the effect of water on the bean plants, I can only change the amount of water. All plants have to be beans, all plants have to be in the same amount of water, all plants have to have the same amount of sunlight, all plants have to have the same air quality, the same temperature. And again, I forget what I said that I was going to be measuring, but if I was going to change the amount of water, that would be the only thing that I'm going to change. The control is what is kept the same. Water would be kept the same. The sunlight would be kept the same. The air temperature would be kept the same. But your control plant would be the plant that just has a normal amount of water. Your variable would be like 20 extra mils of water, 30 extra mils of water, and you would add that to different plants, not to your control plant. Your control plant still has water, just a normal amount of water. Fair experiments only have one variable, that you are changing only one thing, and you're monitoring it, and you're following specific steps. If you have more than one variable, you have no idea what actually caused the change to your plant. So if I change the amount of sunlight and the amount of water, but keep the amount of sunlight and water the same for 2 other plants, and then I'm trying to compare, I don't know whether the sunlight caused the change or if the extra or the less water made the change. So it's only one variable changed at a time. One for a fair experiment. When you're graphing, you're going to graph the dependent variable by the independent variable. So the dependent variable is what you're measuring, and that goes on the y-axis. And your independent variable is what you change, which go on the x-axis. And so if I'm doing this, and I'm going to try and see if I can pull up my draw tablet here, which I don't think I can. I'd have to be over the smartboard, so I'm not going to do that. You would actually have a line. Well, I'll show you this in class, but you're going to have like a graph. What you're changing goes across the bottom. So you're going to have like the amount of water. 20 mils, 10 mils, 30 mils, 40 mils. And then what you're measuring is the plant growth. That goes up your Y. So data, again, is quantitative or qualitative. Do you remember which one's easier to graph? Quantitative. Error is things that we do unknowingly that affect our data collection. Can you think of a source of error? Sources of error could be like measuring wrong, knocking, spilling, not properly putting the right amount of water into the graduated cylinder, the equipment being off, the batteries being low, and that measuring properly. I could go on and on and on. Error is human error usually. So there's a little dilemma here. You wanted to conduct an experiment on how to grow more tomatoes in my garden. I think watering and fertilizing the plants will make them have more tomatoes. I took 2 tomato plants, plant A and plant B, and I watered and fertilized plant B twice as much as plant A. Plant B produced more tomatoes than plant A. Is this a fair experiment? What do you think? So, it is not a fair experiment because there's 2 variables. You cannot water and fertilize plant B twice as much. Could you water plant B twice as much? One time. And then in another experiment, fertilize plant B twice as much? Yes. You would have to do them separately, but not together. Could you try it together at some point? Sure, but you can't do twice as much. You would have to keep your A plant then watered twice as much. So this is not a fair experiment because you're changing 2 variables, not just one.